NeoTech Process, where next-gen factories, robotics, and sci-fi engineering come to life. Above a sleeping city, a gravity-defying car drifts past towers, born from a colossal hidden factory. Here, gravity's contract is rewritten using AeroSilk, threads of aerogel spun in zero-pressure silence. The AeroSilk Gravity Car glides like frozen mist, its translucent skin woven from ghostly glass-like fibers. Instead of forged metal, robots spin its body, turning liquid light into threads that redefine structure.
Each aerogel silk filament is 91% empty space, yet forms a gravity negotiating lattice.
To create this impossible material, we enter a gravity-silent factory, a cathedral of glass and vacuum. Here, assembly begins with simple matter: purified sand, captured carbon, and ultra-clean air stripped of impurities. Nearby, towering bioreactors glow softly, growing engineered silk proteins designed to align and lock into crystalline strength.
Microscopic visualizers show protein chains unfurling and self-organizing, rehearsing the invisible backbone of every future thread. Robots channel this living solution into shimmering zero-gravity reservoirs, creating silk dope infused with aerogel precursors.
Above, transparent vacuum spheres await, evacuated nearly to nothing, prepared to host matter in true near silence. Hair-fine nozzles extend inside. Electric fields coax streams of silk dope into the pressureless void.
Water flashes away instantly, molecules lock, proteins untwist and freeze, forming ghostly aerogel silk filaments.
Scanning lasers trace each newborn thread, while nano actuators continuously adjust fields, tailoring density and pore geometry.
A finished filament emerges, barely visible yet incredibly strong. A functional artery ready to shape the car. Hundreds of these threads converge inside the weaving sphere, a dim hall bathed in deep blue. Multi-armed robots braid filaments in 3 dimensions, sculpting a hollow, cocoon-like chassis from intersecting light lines. The weave grows thicker around cabin and support zones, thinning to airy latticework where lesser forces flow. Now, gravitic metamaterials are added, heavy element nanoparticles prepared to bend gravitational influence like lenses bend light.
Ionized mist floods targeted fibers. Acoustic waves sculpt invisible pockets. Robotic gantries lift the completed shell, gliding it toward the integration hall for systems, control, and propulsion.
Inside, superconducting loops thread through the lattice like veins, while impeller rings attach at gravity control nodes.
Denser AeroSilk forms the interior. Robotic presses mold seat shapes as interfaces print directly onto living fabric.
Finally, nano-ceramic coating flows across the body, sealing pores while leaving the woven skeleton beautifully visible.
In the test chamber, the nearly weightless car rests on a sensor floor, registering surprisingly little mass.
Control systems awaken the aerogrid. Current surges through superconductors as internal fields begin negotiating gravity itself.
Readings plunge, practical weight evaporates, though the chassis still touches ground, almost forgotten by Earth's pull.
Impeller rings whisper to life, lifting the car centimeters clear, suspending it like an idea lightly pinned. Outside, over a structured test city, the AeroSilk car glides along invisible paths between gleaming towers.
It banks smoothly, follows vertical docking strips, and maintains a calm interior bubble where passengers feel steady downward.
From layered sky lanes to mountain villages and coastal transport corridors above freed ground levels, AeroSilk makes gravity flexible. Yet it remains a car, a familiar vessel, where choosing a destination simply reshapes how you fall. We have learned to weave weight itself, spinning matter so light that falling becomes an optional behavior.
Once we asked how to move. High above abandoned asphalt, a single AeroSilk gravity car follows a road only its fields can feel.
If you enjoy the video, please like, comment, and subscribe for more.